So our topic today is hidden sadness detection and differences between men and women. So the overview of the paper and the presentation is we will be talking first of all about the general differences between men and women in their emotion expression, as well as turning a highlight towards the age between people and how age can also affect the emotion expression and detection. We'll be talking about microexpressions, and that's what we will have our focus on. We will talk about precision in detection, and we'll be talking about the existing databases, and we will propose a new database used in, generally in more precise emotion expression, and the new database has more spontaneous and honest microexpressions. So. Okay, before we start with all of this, we have to define emotions. So emotions can be defined as short-lived psychological phenomena determined by aspects which govern the behavior of an individual, which is responsible for its well-adjustment to environmental changes, and especially the social environment. So the influencing aspects of behavior are, for example, bodily changes. So from this definition of emotions, I would like just to emphasize that it is a psychological phenomena. I would also like to emphasize that it is adjustment to the social environment, and that we have, that we notice emotions through bodily changes. So this will be very important for later. Emotion recognition implementation is something that is widely needed, and it is very fast evolving. I mean, for decades now, we are using it in, for example, marketing. We are examining children and people while making commercials. We are analyzing their eye movement, their emotion expression, generally how the commercial affects them, but not just commercials. We have a lot of new things, and the general implementation will be even larger and wider as time goes by. As you name it, if you see now, we're having the online conference, online lectures and stuff like that, so we will be needing it a lot. Now, what I want to focus on when talking about emotion expression and recognition is actually microexpressions, and those are properties of facial expression. They're very brief. They're lasting just from 0.02 to 0.2 seconds. So very short, less than a second, much less than a second. And they are showing actually hidden emotion. But when we see that it is a hidden emotion, we don't know if the concealment is deliberate or not. But microexpressions are actually the real sign of an existing emotion. So generally, the link between emotions and microexpressions is this bodily change. When we're talking about emotions, it is something that we cannot control. When we feel an emotion, we have a bodily change, for example, a microexpression. So the greatest challenge in microexpression recognition domain was the deficiency of a specific emotion aimed spontaneous microexpression database. So generally, we have this problem with the adequate databases that can actually show us and actually to help us really have a good results in emotion recognition, because most of the databases, even if you see it on the internet and different experiments done and stuff like that, you see that the emotions are very exaggerated, like very big frowns, you know, when they're smiling, it's very exaggerated. So, and in the real life, where we really need implementation of emotion recognition, we don't have any use of really exaggerated emotions. So it is very important to notice the gender differences, and this is when we come to the those highlighted words in the definition of emotions and when we're talking about the social environment, because the main difference between males and females and their emotion expression is actually the social environment, meaning what is socially acceptable or unacceptable. So generally, it is concluded and proven through numerous researches that females do express emotions more intensely, but also they express a wider range of emotions than males. While males express the same level of emotion, but on physiological level, or even larger. For example, they have higher heart rate or cortisol level or something like that. But in their facial expression, they do not express the emotion intensively. So when we're talking about the implementation of emotion recognition, we cannot measure people's heart rates on a mobile app or something that easily. It's much easier, or generally, even when we're talking face to face with someone, we do not know their heart rate, but we do see their face. So point being is that females do have more expression when showing emotion, and they can show more of like positive emotions as happiness and kindness and stuff like that, while males, it is socially acceptable for them to show aggression and anger and not to be so, let's say, soft in the general terms speaking as females. But there are emotions which are not socially acceptable for neither gender, whether it is the emotion itself or the circumstance in which the emotion is expressed. And those emotions are hidden emotions, and this is the topic of the paper. But the hidden emotions are not the same as neutral emotions. So even though if they might appear on the face the same or very similar, maybe we cannot register them with our eye and in the conversation, they are not the same as neutral emotions. So when we're talking about age influence, this will be just a short, just to go through it and say that we have to take into consideration age as well, because age, of course, we cannot take, if we are comparing male and a female, we cannot compare a male who is younger, for example, an adolescent or a teenager, let's say 16 years old, and a woman who is in her 45th year of life, and because they have different facial features. So the boy, the male in this case, is more soft, it has softer features, while the woman maybe has more rough features. And this stereotypical gender traits perception is weakened when men and women who have the same maturity of the face are put into comparison. But so if we take, for example, a woman who is in her 25 year of age of life and a boy who is 16, now we can say like, okay, this is we have to all again take into consideration their maturity level, because now they seem on the same level, but they are not. We did not pick a male who is who's also 25 and a female who is 25, but we picked so both have soft features but are of two different genders. So this is where the problem is actually, not just when we have for example, younger male and older female, but the real problem is when we have them looking of alike, you know, so the soft boy and a female. So but why is that important? Because those who seem more affiliative are perceived as expressing happiness, and those who seem more dominant tend to be perceived as expressing anger. So this is just when we are doing the experiments and everything else, we have to take into consideration this as well. So to go brief through the existing databases, the challenges are, as we said, so that there are not adequate enough of adequate spontaneous databases. The most of the databases are having exaggerated showing of emotion. So what is rarely taken into context is the gender. as we were talking about it here, various age categories. It is not evaluated during a candidate position. So this is what we were talking about previously. And just to remind ourselves, what are microexpressions? They are involuntary actions, and the difference between involuntary and the voluntary action is significant, meaning the exaggerated facial expressions and microexpressions are very different, and we need more microexpression recognition in the emotion recognition implementation today. So existing databases, there are four. The first is the Chinese Academy of Science microexpression database, and there is an improved one, and also two more. This is the spontaneous SMIC and SAMM. So just to go brief through them, the point is that, so what are their labels and which emotions do they take into consideration? SMIC has positive, negative, and surprise. And you can see on the slide that positive is some happy emotion, those affiliative people who tend to see more affiliative. Negative is including sadness, fear, and disgust, and they have a surprise. So the Chinese one has 5 basic emotions, and added on those 5 are tense and repression. But the new version has tense and repression kept, and from the 5 basic ones, only happy, disgust, and surprise are counted in, while the SAMM has the 5 basic emotions, contempt, and disgust. So what do we have here? What we are proposing, but in the context of recognition of hidden sadness, now we have to consider this, because the previous ones weren't adequate enough, so we made a new one. We have 3 labels, so sad, neutral, and blocked. Sad is representing the obvious sadness. Then we have neutral and blocked, so those are the hidden, representing the suppressed hidden sadness. So also in the blocked classifier, hidden sadness includes several additional emotions, including disgust, aversion, fear, contempt, anger, etc. So when we analyzed our database, we divided the face into several regions, which is upper part, a middle part, and lower part. Upper part included forehead, eyebrows, and eyes, and middle part included nose and cheeks, while lower part included mouth and chin. Also, regions were observed by minute and the changes registered. So we had a video recording students on university premises. And then later the frames were extracted from the video. Also, what is important to notice when we're talking about this database is that, so the point was to register the hidden sadness. So the students were recorded watching a sad scene from a movie, and they knew that someone can enter the room at any minute. So this is why they would maybe tend to hide or try to suppress some emotion. So masking sadness is done by showing more appropriate emotions such as smile, surprise, anger, and disgust, and not sadness, because sadness is not socially acceptable emotion. And we have signs of suppression, blocking and hiding the expression of sadness is the following: lowering or raising the top and head turns to one side, swapping the gaze direction, and frequent changing of the posture. So the results are following. Before we applied the algorithms, we did the feature extraction. We pulled 68 coordinates on the human face. We used DLib, we did an alignment, and when all is said and done, we can see that sad emotion was difficult to detect, but we'll see later the detailed results. So we did 3 tests. First, we tested 2 males, then we tested 2 females, and the third test was 2 males and 2 females. So we applied 5 algorithms: neutral network, random forest, support vector, machine logistic regression, and KNN. So, but for the training set, we used the same portions in all experiments. So the first test, what you can see on the screen are just the best results in the experiment. So when we were testing on 2 males and 2 females, we can see that the best is that the highest accuracy is achieved when recognizing the sad emotion. And we use the training, for training, we use the random forest algorithm using just male samples. The second best was detecting neutral emotion with highest accuracy of 99.93%. Again, using random forest, again on just male samples, and the hidden sadness detection or block. So the point of the paper, it had the highest accuracy of 73.11% using KNN, again, just on male samples. Now, when tested just on males, here we have a better result when detecting hidden sadness of 79.98%. And for the training, we used again male samples, and the algorithm used was logistic regression. According to the results for all classifier, we can see that the sad emotion was difficult to detect when we tested just males, and this is according to the first premise on the beginning of the paper that males tend to absolutely hide such emotions. And we have neutral emotion with the highest accuracy of 100%, and it is for the training is used a random forest, again using just male samples. And when we tested just on females, now we have the highest accuracy of hidden sadness detection, so block, of 81.06%, again using KNN algorithm. Also male samples, sad emotion and neutral emotion have the same highest accuracy of 100%, and the same algorithm was used, random forest, again tested, again using just male samples, sorry. So for the conclusion, we can say that training performed just on male samples presented the best performance. As you can see, there was no best result that was that for the training was used, I don't know, a female or mixed, just male samples, and the performance is achieved in all experiments. Hidden sadness and obvious sadness is easier to detect for the female population, as you saw it. So this is according to the first premise that women do show their emotions more intensely, and therefore the hidden and obvious sadness is easier to detect in females, even though they tend to hide sadness and anxiety. And for the performance of algorithms, we said again that the results the best results were when trained only on male samples. And for the final conclusion, we have a positive outcome that real and high precision prediction can be achieved. And what is also most hopeful is that the very high and real precision was achieved on the samples that are not highly expressive, so the male ones. And therefore, in real life application, we can say that we can really achieve a very good result. So the reference samples in the databases are the ones usually met in everyday life. So the ones that are not emotionally exaggerated. So while the general databases where the emotions are exaggerated do not give the best results, because in real life we do not show that intensely emotions. So that is it. If you have any questions, and thank you for your attention.
Okay, so I have a question about a database.
Okay.
So how many subjects people for building database?
I just have to, I think it was, Vuk is here.
Hello.
Yes.
It is 19,
19, yeah.
90.
people,
19.
yes, and each person is recorded around 15 or 20 minutes.
Mm-hmm. Okay, yeah, so is it enough to build the database and so check the generality of the result?
Well, it seemed as it is. So, I mean, it seemed the results were good, but it is a good question generally. Is it enough?
Okay.
The results were good, very good, but I do wonder myself also, like in some different in some different I don't know, let's say we're trying to develop an application and then someone else uses it. I think it should be, because generally the point is that those that the best results is were achieved on the samples that are quite neutral, quite you know, seeming as if, you know, they're everyday people trying to hide emotions. So in that sense, I think that it is sufficient. But I guess that with this kind of approach, maybe a higher database for sure would have better results. But generally, I think it is applicable to certain solutions.